Hi everybody, today I'm going to demonstrate the secure SD-WAN capabilities of our FortiGates running FortiOS 6.2. One of the prime benefits that SD-WAN brings is better visibility into applications and the ability to steer application traffic dynamically in order to prioritize business critical traffic and increase application performance. FortiGate Secure SD-WAN steers and secures a broad range of over 5,000 applications. So what you see here is our favorite fast food chain Burger Palace's network topology. Burger Palace is looking to move to SD-WAN, and these are the reasons. They're going through a digital transformation and are using SaaS applications such as Office 365 and Salesforce. Burger Palace also wants to ensure collaborative tools such as voice and video are used to enable global collaboration. And 3, they're also looking to reduce WAN OpEx spending. Now, let's take a look at how Burger Palace can do this. As you can see, we have a broadband internet link on WAN 1 with a cost of 5 and MPLS link on WAN 2 with a cost of 10. We also have 2 VPN tunnels from branch to data center and an LTE connection as well. All of these interfaces are members of our SD-WAN. Most of the traffic is backhauled to the data center, but we also want to break out some SaaS application traffic directly from the branch to the internet, and at the same time make sure that the traffic is secure. One thing that we've added in FortiOS 6.2 is the ability to assign costs to each link or SD-WAN member. We'll get into how to use this later on in the video. So the first step in helping Burger Palace accomplish their goals is to create a rule that preferably sends SaaS traffic directly out the public internet and fail over to MPLS in the event a brownout occurs on our broadband link. So to do this, first of all, we have to go and create an SLA for our SaaS traffic. So let's go to Performance SLA. And here we've already created an SLA for SaaS traffic called SaaS SLA. So this is where we configure our parameters for our SaaS SLA. You'll notice that we are using HTTP to a couple of URLs from Salesforce and Microsoft respectively. And that's because Burger Palace is using a combination of Salesforce and Office 365. So we'd like to get a better approximation of what kind of latency, jitter, and packet loss that our links will be experiencing when trying to reach both Microsoft and Salesforce. One thing that we've added SLA values for different types of traffic. So if you're creating an SLA for cloud traffic, you can select the pre-created cloud SLA template for SaaS traffic, or you can customize these values based on your own preference. If you want to take it a step further, you can look up your application and also find recommended values for that particular app. So if I type Office here, we have recommended values for Office 365, and you can do it this way, and once you click this, it will auto-populate these right here. Okay, so now that we have our SaaS SLA set, before we move on, one last thing to point out is that if you highlight this SLA, you'll not only be able to see the real-time latency, jitter, and packet loss values, you'll also be able to see the historical values of these characteristics for your selected links in this SLA. So SD-WAN rules is where you actually create the policies that tell the WAN path controller where you want to steer different types of application traffic. So Now let's go and create our SAS rule. I'm going to name this rule SAS. And all. So now let's add our applications to our SAS rule. We've already created a custom application group named SAS that contains all of the SAS applications that Burger Palace would like to steer. And as you can see, it includes a lot of Office 365 and Salesforce applications and sub-applications. So let's select that. The next step is to choose our application steering strategy. In 6.2, we've expanded it to include 4 distinct strategies. Manual simply steers an application over a specific WAN link. Best quality dynamically selects the best performing WAN link based on user-selected criteria. So it could be latency, jitter, packet loss, or a combination of all of the above. Lowest cost steers based on link cost assigned to each SD-WAN member. And if you remember, we did that in the previous step. The member with the lowest cost that meets SLA will be selected. If costs between 2 or more members are equal, then priority will be used as the tiebreaker. Maximize bandwidth will load balance applications within the same rule between the selected SD-WAN members. So going back to the rule, let's choose lowest cost as our strategy. And if you remember, WAN 1 has a cost of 5 and WAN 2, which is MPLS, has a cost of 10. Our SAS traffic will always be sent over the WAN 1 public internet link unless it fails SLA, in which case traffic is then automatically steered to the SD-WAN interface member with the next lowest cost, and in this case, it's the MPLS link. Next, we'll choose our SAS SLA as the SLA in which the WAN links here are measured against. Click OK, and we're done. Securing SAS traffic that is traveling on unsecure public internet is extremely easy with the FortiGate. Whereas with some pure play SD-WAN vendors, you'll need to bring in another security solution. On a FortiGate, simply go to your SD-WAN access policy, and check the boxes of all the security features that you wish to enable for your SD-WAN traffic. It's that easy. Next, let's create a rule that sends VoIP traffic down the WAN path that always has the best quality. Let's name it VoIP. For this rule, let's create a VoIP application group, and we'll add the relevant VoIP apps for Burger Palace. Once we have our VoIP app group created, let's add it as the destination. Next, choose our strategy, which in this case is best quality. For our purposes, Burger Palace has determined that latency, jitter, and packet loss are all equally important for their voice traffic. So let's add our 2 VPN interfaces, select our link health measurement target, select custom, and give each of these 33%, 33%, and 34% respectively, and the SD-WAN will select the best performing path of the two based on real-time performing metrics. Since voice quality is very important for Burger Palace, having some form of WAN link remediation will go a long ways towards achieving that. In 6.2, we can now perform forward error correction on these VPN tunnels to help recover from packet loss or other errors. As you can see, with the help of FortiGate SD-WAN, Burger Palace was able to successfully adopt digital transformation by gaining more application visibility and better application performance without compromising on security. All of the configuration we've done so far was done on a FortiGate. For larger deployments, the same exact things can be centrally done from FortiManager. FortiManager is the orchestration and management platform, and FortiGate is the edge device. The same SD-WAN members, SLAs, SD-WAN rules can be configured once and saved as a template or templates so that it can be pushed out to hundreds and thousands of branch offices. We'll cover this in a future video. We also make it very easy to onboard new devices for secure SD-WAN deployments. With the help of zero-touch provisioning, when a new FortiGate is deployed at the branch, it is automatically connected to the FortiManager and receives all the SD-WAN and security configurations. We have customers that use this process for over 12,000 sites. Hope this has been helpful, and thanks for watching.